All right, so let's take a look at this one here. It's page 480, number 11. So here they give us this plane in Cartesian form, and they want us to find the vector and parametric equation of this here. Okay, so does anybody want to give me a starting point? So I have this plane, and the only thing I really have is the normal vector. Okay, but what I want is I want two direction vectors. Okay, so can anybody give me some ideas as to what I might do to easily find? And there's a couple of options for solving this problem, but I think there's one that's a little easier. So what else am I going to need besides the direction vectors? Okay, so one option here is to find the X and Y and Z intercepts, because you can find 3 points on this plane. Now you're going to need a point anyways, okay, to find the vector and parametric equation, and then you can find 3 points that you can then use to find two direction vectors. Okay, so you're going to need an A vector and a B vector as your direction vectors. All right, now the suggestion to find the X, Y, and Z intercepts is a good one, especially in this scenario, because you look at your D value, which is 6, and you look at your A, B, and C values, and they all divide 6 perfectly. So if they didn't necessarily divide 6 perfectly, I might choose other points. But here, if we let X equals 0, and Y equals 0, what are we left with? We're left with negative Z plus 6 equals 0. So Z equals 6. So there we go. 0, 0, 6 is one of my points. If I let Y and Z be 0, I'm left with 3x plus 6 equals 0. So X is going to be equal to negative 2. So negative 2, 0, 0 is a second point. And now let's let X and Z be 0. So we have 2y plus 6 equals 0. So y is equal to negative 3. So 0, negative 3, 0. Okay. And then from here, we can create two vectors. So let's say I create my vector A. Okay. And I'll do the subtraction here. So what do we have? We've got I guess I'll do this minus that to keep some positive numbers. So 0 minus negative 2 is 2. 0 minus 0 is 0. And then 6 minus 0 is 6. Okay. And then here B is equal to. And let's do the same thing with these two. Okay. So 0 minus 0 is 0. 0 minus negative 3 is 3. And then 6 minus 0 is 6. Okay. And now I can use any one of the 3 points with these two vectors. Okay, if I wanted to, I can even simplify these vectors. Okay, I can use, sort of A prime, can use 1, 0, 3, just multiply by 1/2. And here maybe B prime, again, multiply by 1/3, 0, 1, 2, and use these two vectors, because any two vectors that are parallel to the plane can be used. And so my equation, or at least one equation that I could write, say is 0, 0, 6 plus S times 1, 0, 3 plus T times 0, 1, 2. And S and T can take on any real value. And there you go. There's one equation of the plane. Now, obviously, there's many ways to do this. So there's many possible equations that we can write out. That's the inconvenient thing about vector and parametric equations. Okay, any questions about this here? No? Okay, so we'll stop it now.